All right, hello everyone. I wanted to go over these notes really quickly, just so you can fill these in case you missed these today in class. So like I said, I'm just going to go through these pretty quickly, just hit the high points, and then let you see all the slides. So sedimentary rocks made of sediment, pieces of other rocks, basically, and only about 5% of the crust is made of sedimentary rock. All right, so we'll see this slide again. We'll go through some steps, and then you can fill these in as I go through them. All right, so how about this? All right, so the first one, weathering. Let me do this. Weathering, rock breaks. So weathering happens, big rocks break into smaller pieces. Then erosion takes place. And those rocks, the sediment moves somewhere else, so it moves downhill because of gravity. Water is the biggest agent of erosion, then wind. Then deposition takes place. So it reaches some place where the sediment doesn't move anymore and is deposited. Then you have compaction from other layers of sediment on top of it, pressing down and squeezing that. And then eventually, through some other processes, but eventually there's lithification where all that sediment that are separate little pieces then becomes one cohesive rock through the process of lithification. And lithos means rock in Greek. So hopefully you have something that looks like that. Switch that, oops, switch it again. So it looks like that. So weathering, the rock breaks. Erosion, rock moves. Deposition, rock stops moving. Compaction, rock gets squeezed. Lithification, sediments turn into rock. And lithos means rock in Greek. Okay. Types of sediment. The finest is going to be clay and then silt. Other than that, it gets much bigger. I'm not going to ask you to memorize this or anything. Sand tends to be the largest sediment that can be moved around by wind, aside from during tornadoes and stuff like that. But it doesn't really count. All right, so on to types of sedimentary rocks. Clastic. Clastic means broken. So clastic sedimentary rocks are made up of pieces of other rocks. So again, through the same process that we just talked about, those pieces, that sediment, those fragments of broken rock are compacted. And so pressure is exerted on those to compact those, and then those are cemented together with minerals. Those minerals are dissolved in water, and the water seeps into those layers of sediment. The water evaporates and leaves those minerals behind, which then cement everything together. Some different sediment sizes. The larger sediment, gravel and pebbles and sand, and then on down to silt and clay. Sediment sorting. There are a couple ways to look at this, but it's the same concept. So as water moves downhill into that body of water, it's going to slow down when it hits that body of water, when it becomes part of that. So when it slows down, it's going to lose energy, and it's not going to be able to move sediment the same way, and it's not going to be able to move as large as sediment or as larger pieces of sediment. So it's going to drop that gravel first because that's the largest piece. Then sand is going to keep traveling, and it's going to drop that after it slows down and loses more energy. And finally, silt, which is the finest of the three, is going to be carried the furthest. So you can think of it two different ways. You can think of it as the largest pieces of sediment being dropped or deposited first, or the smallest pieces of sediment being carried the furthest or traveling the furthest distance. Like I said, it's the same concept. It's just which way you want to look at it. And this kind of shows that we have larger pieces of rock up here close to the source of the rock, that cliff face, and then smaller pieces you get closer to the water line. And then permeable, so that means the water can pass through it, and that all depends on the size of the sediment. And then, the larger the sediment, the more gaps in between those pieces of sediment, the more gaps and the larger the gaps are going to be. So it's going to let water pass through more easily. If the rock is made of something that is a sediment that's very fine, it's possible that those pieces of sediment can pack together so tightly that there aren't any gaps, so water can't get through. So if water can get through something, then that material is permeable. Just like in biology, the cells have a semi-permeable membrane. Some things can get through, some things can't. If it's something like clay here, where it's on the right, that it's packed together so tightly that there aren't gaps, there aren't spaces, then that's something that would be referred to as impermeable. Water can't pass through it. With chemical sedimentary rocks, minerals that are dissolved in the water crystallize either through precipitation, so the crystals form within solution, or during evaporation, as water with dissolved minerals in it turns to water vapor, it doesn't take those dissolved minerals with it. It leaves all that stuff behind. So, over time, those minerals can form structures and get larger and larger over time. A few things. So limestone, which is, kind of big here in Indiana, that's cemented together with calcite, which, as you remember, maybe not, is a carbonate and will react with hydrochloric acid by bubbling and fizzing and all that, dissolving. Halite is essentially rock salt, and rock salt isn't really a rock, but just a large crystal. And gypsum, these are just a couple of pictures of salt mines, like actual salt mines. So everything in there, the floors, the walls, the ceilings, all that is salt. And what's this part of the surface? Organic, or sometimes called biochemical sedimentary rocks. So because it's organic, it has pieces of plants or animals or something like that. So it's like coal, and then here we have shells, like little snail shells, seashells that are cemented together with minerals. Sedimentary features, so layers, that's the big thing. I mean, with sedimentary rocks, I mean, it's a key feature, it makes them easily identifiable. Ripples, so the one on the lower right is a modern picture, where there's still water, it's not rock. But those are ripple marks created by wave action at the shore of a body of water, and those can be preserved in rock. So scientists, if they find that, they know that there was water there at one time. Same with mud cracks. So if the soil has a lot of clay, very high in clay, if it's an area where there's a lot of water, and then that water dries up, then it can crack the surface like this. And again, that can be preserved and be an indicator as to the the climate in that area in the past. And then geodes. First off, not all geodes look like this. Most don't. But these form as they start out as a hole or void or a bubble in rock, and then water that has minerals dissolved in it, finds its way into that cavity, and then crystals form. So that's how they form. And like I said, they don't all look like that. And then fossils, the last thing, these are found in sedimentary rocks. The quality of the fossil and the amount of detail that you get from the fossil, which is just a remain of ancient life, depends on the size of the sediment that it's in. So something that's in sand, or sandstone is, going to be okay, but it's not going to show you as much detail as something that was in, silt or clay or something like that, because that has smaller pieces of sediment, so you can get more detail. So hope that helps. Hope everyone's doing well. take care, and I'll see you.